Hello everyone, myself Indumati. I'm teaching associate in the Department of Computational Intelligence in SRM IST, Katangulathur. Today we are going to discuss about the fuzzy C-means clustering algorithm. Fuzzy C-means clustering algorithm is an extension of K-means algorithm. That is, we know that in a hierarchical clustering or K-means clustering algorithm will always generate a different partitions, and in each and every partition, data for based on the similarity, similar features and similarity measure, each and every data point will be stored into separate clusters. That is, each data point can only be assigned in one cluster. But in fuzzy C-means clustering algorithm, which will allows the data points to be assigned in not only the single cluster, we can assign the single data point into a multiple clusters. So for that purpose, we need a new terminology called the degree of membership. So whenever we are using some uncertainty concept, because a single data point can fall under first cluster or second cluster or third cluster, we are supposed to use the probability concept. So for each and every cluster assignment, we need to provide some weightage based on the probability. So these are the steps which we are going to follow for fuzzy C-means algorithm. The first step would be randomly initialize the membership matrix using this particular equation. So the main constraint here is the membership function or the membership value can be used by this notation, represented by this notation called mu I of xi, right? So if you have a multiple clusters, for each and every cluster, if you're going to assign one particular data set or data point, for that we are supposed to give some membership value. At last, if you are adding all together, that should be 1. That is what your first step. We will discuss this with one numerical example so that you will get a clear understanding. The second step is calculate the centroid using this particular equation. Cj is equal to summation of mu I of xi the whole power mxi. Here m is nothing but membership or fuzzification parameter. So please note it down. M should be range between 1.25 to 2. So within these two value only we are supposed to assign the m value. M is nothing but it's a fuzzification parameter. Since we are going to assign a single data point into a multiple clusters, we need this fuzzification, right? And divided by summation of mu I xi whole power m. This is the formula for calculating the centroid. And the third step is calculate the dissimilarity measure or between the data points and centroid using the Euclidean distance formula, and then update the new membership matrix using this particular equation, right? And then we can go back to the step 2 unless the centroids are not changing. Till you reach the convergence state or phase, we are supposed to follow these steps. From step 2 to step 4, we need to do the same step in an iterative manner till you have reached the convergence point. Okay, so just consider here we have a total of 6 numbers, 6 data points with 2 features x and y, and the number of cluster itself provided in the question, which is nothing but 2, right? If you want to form a 2 cluster, that is, in fuzzy C-means clustering algorithm, this single data point 1, 6, this single data point 1, 6 can fall under C1 as well as C2. So for that purpose, we need to provide the membership value, degree of membership, right? So how much possibility, that is, what is the likelihood of this particular point 1, 6 being in the cluster 1? So which is nothing but 0.8, and for cluster 2, the chances of falls under cluster 2 is 0.2. If you add these two membership value, finally will be getting 1. In that manner, we are supposed to randomly assign the membership value, right? Now for 2, 5, for cluster 1, the high chances, which is nothing but 0.9, and for cluster 2 it is 0.1. For 3, 8, it falls under C1 with 70% of chance, and it falls under C2 with 30% of chances. And 4 comma 4, 30% and 70%, 5 comma 7, 50-50, and 6 comma 9, 20-80. So this is how the first step, that is we are supposed to randomly initialize the membership value. So once you got the initialized membership matrix, then find the constraints using the equation like centroid value. We can substitute the centroid value. So if you closely observe this particular formula, since it is a two-dimensional data, we are supposed to use two-dimensional format, right? Now, the membership value with the first data point with respect to first cluster, with respect to second cluster. So the membership value associated with this particular first data point for first cluster is 0.8 and the second cluster is 0.2. So that is what mentioned here. 1 into 0.8 the whole squared, because I have mentioned m as 2, right? Plus you just use all x points here and y points here. So x points are 1 into 0.8 whole squared, 2 into 0.9 whole squared, 3 into 0.7 whole squared, likewise 6 into 0.2 whole squared. That is what mentioned in the numerator part of this particular portion, and divided by simply substitute with the membership value, right? Here in the denomination, 0.8 the whole square, 0.9 whole square till 0.2 the whole square. The x part is over. Moving on to the y part, same way, y value into 0.8 whole squared and till 9 into 0.2 whole squared, right? Now you'll be getting the updated cluster value or initial cluster value, which is called as 5.58 divided by 2.32 and 14.28 divided by 2.32, which is nothing but 2.4 comma 6.1, right? And this is for the first cluster centroid. Same way, use the same formula and approach to compute the second cluster centroid point. For that, what we are supposed to do, instead of considering the first cluster probability value, you just consider the second cluster probability value, that is 1 into 0.2 the whole squared, 2 into 0.1 the whole squared, 3 into 0.3 the whole squared, till 6 into 0.8 the whole squared, divided by all the membership value, comma y value, right? So 6 into 0.2 till 9 into 0.8 the whole squared. That is what mentioned here. If you closely observe, you will be getting, the only membership values have been changed in this formula. That's it. After this, you will be getting the updated centroid as 4.8 and 6.8. Then the third step is simply use the Euclidean formula to compute the distance between each and every cluster value. So for the first centroid, compute this Euclidean distance, you'll be getting this particular distance value, right? And for centroid 2 also, see the centroid, updated centroid 2 is 4.8 and 6.8, and compute the distance, you'll be getting 3.8, 3.32 and till 2.50. Once you got the distance, now it's a comparison part, right? So for cluster 1, for this data point, the distance is 4.40. For the same data point for cluster 2, it is 3.88. This is what the consolidated distance computed distance values. Now we can update the membership value based on the observed distance value. How do you update the membership value? Which is nothing but 1 by the distance value whole power 1 by m minus 1. We know that we assigned m is equal to 2. So I and j is the first data point and j is the first cluster, right? For each and every cluster, simply substitute the value and compute the distance. So for mu 1 comma 1, for the first membership value, 1 divided by d11, that is nothing but the first cluster first data point distance, first cluster second data point distance, first cluster till the last data point distance. D11 1 by 2 minus 1 divided by d11 1 by 2 minus 1. Likewise, you just simply substitute the values, you will be getting 0.7. So for this particular data point, for the first cluster, the observed or updated probability value or membership value is 0.7. Same approach you adapt for rest of all the data points. Finally, you can also use this cluster 2 data points also, distance also, in order to get the updated membership value. Finally, this is what the new membership value for 1,6. The updated cluster membership value is 0.7, and for cluster 2 0.3, and 2,5 it is 0.4, and it is 0.4, 0.6 and 0.4. So likewise the cluster values are updated. If you closely observe, for the first data point, which cluster has the maximum probability value? Cluster 1 is the maximum probability value, so this belongs to C1. And similarly, compared to these two, C1 is the maximum. Here also I just randomly picked C1. Here also I just randomly picked C1. So first 4 data points are belongs to C1. And moving on to this last two, the highest probability value is 0.9 and 0.7. Now continue this process until get the same centroid like this. Okay. So this is how we can proceed with the fuzzy C-means algorithm. The only difference between K-means algorithm and fuzzy C-means algorithm is, in K-means we can assign a single data point with only one cluster, but in fuzzy C-means by adapting the probability concept and using the degree of measure, we can assign a single data point with multiple clusters with a weightage value called probability value. Thank you.